Today's video will demonstrate how to create a counter control loop. Hello, I'm James Helfrich. One of the most common types of loops we create is a counter control loop. This video will define a counter control loop, identify the 4 questions we have to answer when solving a counter control loop problem, and show a few examples of counter control loops in action. A counter control loop is a repetitive control structure that executes a given block of code a fixed number of times. And typically, the number of iterations is known before the loop begins execution. For an example, here I have a flow chart with a typical counter control loop. And there are several parts. In fact, there are exactly 4 parts. The first part is where we start, and it specifies how the counting will begin. The second part is how we end, specifies how the counting will conclude. Next, we have the increment, what changes every iteration. And finally, we have the body, what happens every iteration. Every time we have a counter control loop, we have to answer these 4 questions, and each counter control loop has these 4 parts. So let's start with the start condition. All counter control loops have a starting condition. This usually involves setting the counter variable to some initial value. The default is 0, but it could be any value. So for an example, in Visual Basic, I'm going to start my count as 1, and I'm going up to the square root of n. But notice how I could also go from counting square root of n down to 1. In either of these cases, I'm going to have a different starting condition. So a couple of best practices. First of all, make the starting condition explicit. If your programming language allows you to skip this step, it's a good idea to add it anyway, so it's extremely clear exactly what you're doing. And second, we want to move the complicated code from the end condition to the start condition. So back to our 2 VB examples, notice how that the square root of n is actually rather complicated. We don't want to do this every iteration. We want to do it exactly once, and therefore the second solution is better. The second question is the end condition. The end condition is the same as the controlling Boolean expression of an event control loop. Here you're looping until the end condition is met, or when the controlling Boolean expression evaluates to false. So for an example in VB, I want to go until I hit 1 if I'm counting down. Or in C#, exactly the same problem, I want to continue as long as count is greater than or equal to 1. Note that if the loop were to execute n times, then the end condition will be evaluated n plus 1 times. And therefore, it's extremely important we make the end condition easy to evaluate. The increment part of a counter control loop modifies the counter. And hopefully, every iteration, the loop will move the counter closer to the end condition. Usually by default, the increment is add 1, but in this case, I'm going to subtract 1 using the step in Visual Basic. Or in C#, I'm going to say count minus minus. We'll take the current value and subtract 1. Now, a couple best practices. First, be wary of a counter control loop without an increment statement. If there's no increment statement, it might not advance the end condition, and it might go on forever. Second, counter control loops should have the increment statement in the for loop. In other words, don't put the increment part in the body of the loop, have it in the for loop. And therefore, the person who's looking at your code knows exactly where to find the increment condition. And finally, every loop should have exactly 1 increment statement. If you have 1 or more spread throughout the body, then the program may be much more difficult to understand than necessary. And finally, the body. The loop body of a counter control loop is the same as that of an event control loop. It is executed exactly once per iteration, and the controlling Boolean expression is guaranteed to be true in the body of the loop. And it should be devoid of any statements that do not belong there. In other words, because the loop body gets executed more than once, there's an extra cost to having redundant or unnecessary steps. So back to our Visual Basic example, in this case, I'm going to sum all the values that are less than the square root of n. Okay, let's take a look at a couple of simple examples, and this is all done in Python. Now, what I like to do is I like to sum the values below n. So I'm going to say count equals 0, and I'm going to say while count is less than, let's say, 10, and I'm going to say sum plus equals count. And then I'm going to say count plus equals 1, and I forgot to initialize my sum equals 0. Okay, now observe we have all the parts of a counter control loop. We have the initialization, we have the end condition, we have the body, and we have the counter. However, this is an inferior design because the increment is within the body of the loop. A better design would be to say for count in range, start condition 0, end condition 10, increment 1, and now all the parts of the counter control loop are explicitly mentioned. Where I start, where I end, how much I increment I, and the body. We don't want to have any of the loop control logic inside the body of the loop. Let's take a look at another example here. Okay, I have a bunch of people here, and I want to sum up their grades. So once again, I'm going to use a naive solution, and I'm going to say index of person equals 0. And I'm going to say while index of person is less than the length of people. And then I'm going to say sum plus equals people of I person. And this is going to be the not 0, but 1 index. Sum equals 0.0. Okay. And don't forget, I'm going to say I person plus equals 1. Now, once again, I'm going to have my increment somewhere in the body, and I'm going to have the initialization somewhere not in the loop itself, which makes this more difficult than necessary to understand. So it's far superior to use a for loop for something like this. I'm going to say for I person in range, and I'm going to start at 0, and I'm going to go up to length of people, and I'm going to count by 1. Now, all the parts of the loop control, the start, the end, the increment, all in the for loop itself. The body only contains the body. It's far more understandable. And this is particularly important. What am I going to do when I want to only sum up the subset? Then I'm going to say, oh, I'm going to go from index 1 to index 3, and that'll be Sue and Sly, or to 4, Sue, Sly, and Sid. And in this case, I can make modifications to just one part of the program without having to look anywhere else. And this makes the code far more maintainable. Counter control loops should always be a for loop. You can learn more about counter control loops in the counter controlled section of the loop chapter of the software design textbook.